Okay, we are into chapter 4. I'm going to try to skip around a little bit because functions is what you need to learn out of this chapter. But let's start some background. You guys remember it's better here, the finding slope and the Cartesian plane is what this is called. So you have quadrant 1. Oh, that's really a 1. There we go. And in that quadrant is all plus numbers. And this is quadrant 2. And in that quadrant, you'll have negative and then plus. So negative x plus y. And then quadrant 3, you'll have both negative. In quadrant 4, you will have a positive and a negative. So this is kind of the quadrants of the Cartesian plane. So you guys are used to, like, if you have a Cartesian plane like this, you have your numbers across to here. And then you find your point. It's like right here. And then say you find your other point, which would have been both negative on this side. And then you draw your line through them. You guys are used to that type of Cartesian plane. That is a 2-point system. So speaking of that, there are 4 different slopes that you guys should remember. There is the line that goes this way. Oh, this is horrible. What if I have a line function on here? No. Oh well, you're just gonna have to deal with my horrible lines. There. So something that goes this way, the line leans to the right this way. This is a positive slope. Positive slope. And if you have another one that goes the other way, leans to the left this way, that is a negative slope. Okay. If you have one that goes straight across, that is a 0 slope. Now, if you have one that the line goes straight up and down, that is called an undefined slope. Okay. Oh boy. Now, so let's do a little graphing, just a little refresher graphing. Let's say we want to graph something like y equals 5x. So what you would do is you basically want to substitute x for 0 to start off with. 0. You guys have done this. So y equals 0. And then we'll substitute for the second point. So if y equals 0 and x equals 0, so this would be 0, 0, xy. Okay. Now, if you did it if you substituted x for 1, it would be y equals 5 times 1, and then y equals 5. So your points would be 1, 5. So to graph this, obviously 0, 0 are right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You have 1 on the x plane, 1, 2, 3, 4, 5 on the y plane. So you have something like that. So you just draw a line between them, and there's your line. Okay, that's kind of a refresher. You guys have done this before. Something you guys have also done before is finding slope. Slope. So given something like this, and the slope, you guys remember this M, it means slope. You can plot this on a graph. We only have one point, so we have to use the slope to find the other point. So 0 and then -2, which is right here. Okay, so let's find slope. Slope is -4. So slope would go up, up 1 over 1, then 1, 1, 2, 3, 4. And that will be your next point. So basically we have this line. Well, this, oh boy, this line. Okay, that's close enough. So we found slope by doing this. 1 over to the left because it's negative, and then up 4. Or you could do 1 over here or down 4. 1, 2, 3, 4. It comes pretty close because my lines are not perfect. But that's how you find slope. So this way, and this way, this. Oh, I should have started here. This way, sorry guys. Okay. So today, what we're going to be doing most of the class today is we're going to be using functions. Functions is something new to you guys, I believe, but it doesn't mean you can't do it. It will pull upon your graphing skills, so that's why we kind of went over those briefly. So functions. So for functions, there are 4 different ways to show a function. Now, I guess what is a function? A function is something that if you give it an input, say X, it will always come out with an output. I meant to write Z, but it didn't work out too good. The letters here don't matter. You give it an input, it comes out with an output. So let's look at these. You can do it as a verbal description. which is kind of like a word problem. You can show them as a list of ordered pairs. So a list of ordered pairs would be something like this. So, oh, that's what I want. So just a list of ordered pairs like this can be a function. So for a list of ordered pairs, let's say these pairs here. -29. Okay, so say these list of ordered pairs. To verify this is a function, you have to examine the inputs. If none of the inputs match, it must be a function, since no input occurs more than once. So no input would yield multiple outputs. If two inputs match, the corresponding outputs must also match. So basically, each X value, these here, are different. None of them match. And each Y value is different. None of them match. So this could be a function. And we could write it as a function. Okay. The next one is the vertical line test. So let's say we have a parabola, kind of like this. This is Cartesian plane. This represents y equals 1/4 x squared. And this one is a parabola that runs this way, and it is y, or x actually, sorry, x equals 1/4 y squared. Now, so what this is showing is if I drew a vertical line, let's say here, this vertical line only touches this function there. That's the only place that it touches. So this one is a function. This one, if I draw a vertical line here, it touches it in two places. If it's two places, then this is not a function. And that's how you tell. The last way to find out to a way a function can be represented is algebraically. And that's what we're going to be working on mostly. So given a function y equals x squared, excuse me, if you can solve for y and you don't have to have the plus or minus when you do the square root, then it's a function. If you do have to have these, then it is not a function. Just remember that part. Okay, so things that you'll be doing. You'll be given a list of ordered pairs, say something like this. and 2 and 5. And the question is this a function? Um, so what we have to do is compare the input values for the first 2 points, or for all the points. Does any of these match? And now we can see already that this one and this one match. So this is not a function. Okay, that's how you do that. All right. You'll also be given something like this. They'll give you a Cartesian plane. They'll have you a parabola here. And they'll say, draw a line at -1. So we'll say -1 is right here. You'll draw that line. Is this a function? So how many times does it cross the parabola? Once, right here. Right there. So this is a function. Okay. Or they'll give you an algebraic sentence, something like x equals y, excuse me, squared plus 1. And basically you just solve for y. So to solve for y, we'll move, let's get y by itself. X minus 1, I believe. And then to solve that, we just say y equals plus or minus x minus 1. Now, can we see already that this is a function or not? We have the plus and minus right here. So this is not a function. Okay. And so you'll be given another graph here. And they'll tell you that y equals x cubed minus 2. And then they'll draw that. So come up and over, something like that. Is there anywhere, if I draw a straight line, a vertical line, is there anywhere that it will cross it twice? So I could draw one here, it's not going to cross it, or here, or anywhere. So it only crosses it once, it's a function. So let's look at this one. This one is like this. So this is actually, if you run a straight line through that, crosses it 3 times. This is not a function. Okay. So we're going to look at now evaluating functions. To evaluate functions, we're going to start using something called function notation, where you use f of x to notate your functions. You could have something like f of x equals x squared. And then they'll give you what x should equal if you need to evaluate it. Now, so let's say they'll give you something like this. F of x equals 3x plus 2, where x equals 5. And you have to solve this. So you would say f5 equals 3 times 5 plus 2. And this would be what? 3 times 5 is 15 plus 2 is equal 17. Okay, and if you need to step that out, this is multiplication. 3 times 5 is 15. And then plus 2 is 17. Okay. So let's give some more. So f of x equals 5x squared minus 4x plus 3, where x is equal to -3. And we have to solve this. So we would rewrite it as f -3 equals 5 -3 squared minus 4 -3 plus 3. And let's see, -3 squared times 5 is 45 plus 12 plus 3. And that equals 60. So we could say that f -3, the function -3, is equal to 60. Okay. Here's another example. So sometimes you can represent it as instead of f of x, which I like, you could do g of x or h of x or m of x. It doesn't really matter what this letter is. It's just this notation that they're trying to teach you. I like f of x, but the book will have different ones, just making you aware. So let's use a different one just to make sure you get used to this. G of x equals x minus 4 over 2x minus 3, where x equals 7. So rewrite it as g of 7 equals 7 minus 4 to 7 squared minus 3. Okay, so we will work this like a normal equation. We would get 7 minus 4, that is 3. And then 7 squared is 49 times 2, right? So what's 49 times 2? It's 98 minus 3. So 98 minus 3 is 95. So we would say that g of 7 equals 3/95. Okay. Now, let's do another one. Let's do h this time. H of a equals the square root of a plus 5, where a equals -2. Okay. So to solve this, you would plug in the -2 into this function. Okay. And then we would say that the square root of -2 plus 5, which is what, 3? The square root of 3. So the square root of 3 wouldn't be, it would be represented as h -2 equals the square root of 3. You wouldn't go any further. That's as far as you go. You don't do anything with this side. You don't try to manipulate this side. It's always over here. So that's where you would stop. Okay. And let's try something else. How about function m equals m squared plus 2m plus 1. M squared plus 2m plus 1. Where, this is where the tricky part comes in, m equals q plus 1. Oh, well, that's different. Okay. So we just fill it in. Q plus 1 equals q plus 1 squared plus 2 times q plus 1 plus 1. And that would just use our handy dandy skills to solve this. So how do we solve it? Anybody know? Yeah. Okay. Q plus 1 squared is basically just, okay, let me try to help you here. Q plus 1 squared. Let's take this here, and draw it over here. And let's do it on a side note right here. So Q plus 1 times Q plus 1. That's essentially Q plus 1 squared. So Q times 2, Q times, we're going to use this method here, 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 and here. So Q times Q, Q squared, and then Q times 1 is just Q. 1 times Q is just Q, and and 1 times 1 is just 1. So this can be written as Q squared plus 2Q plus 1. So that's what this gives us. So we'll say equal Q squared plus 2Q plus 1 plus, we're going to use distribution here to Q plus 2 and then plus 1. Whew. Now, let's get everything together. Any more squareds? No. So we're just going to write our Q squared here. Any more Q's? Yeah, there's one right here. So we got 4Q plus 2, 3, 4. Okay, and this is function Q plus 1 equals that. And that's where you stop right there. All right. So for homework, you're already home, aren't you? Oh, well. So we're doing 1 through 29 till odd. So what you'll find is the first section in the homework, 1 through 5, they have ordered pairs. And if you remember ordered pairs in your notes, I don't know if I have it here. Okay, it was in the notes we took a little earlier. But if anything matches on the X side or the Y side, then it doesn't work. Now it's okay if you have an X and a Y that match, but you can't have an X and an X match. All right, 9 through 15, they're going to give you a graph. You have to determine if a vertical line, okay, vertical line is this way, will cross it twice. You can put that vertical line anywhere on that graph to see if it crosses it twice, okay? On page, okay, on number 17 through 23, all you have to do is determine if it's a function algebraically. Now, remember, the way you determine that is if it has the plus or minus as part of the answer. If it has that, then it is not a function. Okay. 25. Actually, I'm going to add and 26 and 28. Okay, so this is an add-on to your homework. So 25, 26, 28, and 29. You evaluate like we have been doing in this whole section here. Just evaluate. They're going to give you the function. They're going to say where, A or Z or F or X is equal to this, and you just have to evaluate it. Okay. All right. Any questions? Let me know. Thank you.